Hi, I'm Vivek and welcome back to this video lecture series called Hands-on Introduction to PINNs. I'm going to share a story with you about how I landed a job interview recently and attempted to solve the job interview question, which was a take-home assignment using PINNs. Was I successful? Was I able to successfully crack the assignment using PINNs? Was it challenging? Was it worth the effort? And should you invest in PINNs? Stay tuned till the end of the video to find out the answer. So I released a introductory video for this series, and we had initially decided to have a video on the universal approximation theorem, but we're still trying things out and testing things out, and we thought that it might be a good idea to just continue our viewers giving you a broader introduction to this area of PINNs so that you can get a better perspective on how PINNs really sits into the bigger picture, and most importantly, it'll help you understand if PINNs are for you and how you can transition to PINNs and how this fits your personal story. So an important topic is always job interviews and landing jobs and getting jobs, and can PINNs actually help you get a job? So I see PINNs as a technology or a method which is going to really help physicists and engineers and scientists in general transition to machine learning. I see it as that bridge, and it might even help you land a job. So today we're going to talk about this. Most importantly, cracking job interview questions with PINNs. So I'm going to guide you through this whole process and tell you my personal story right from applying for the job. Because many a times we might just apply for a job online, putting in a lot of effort, never to hear back, right? So even this first stage of applying for a job is very important. Like PINNs comes down the line, it comes downstream. So securing a job interview is much easier when you actually know someone at the company. So in my case, this is a company I had known for a while and I was interested in through my research exposure, and I have a lot of LinkedIn connections from this company. So one of my connections, who's actually a hiring manager in the team that I'm interested in, posted about a job opening, and I looked at the job opening. I thought it was a great fit, so I thought, well, let's go for it. So I liked his post, I commented on his post, and I reached out to him with a personal message. And it seemed like there was a good synergy, so he asked me to just go ahead and apply officially. And I also did share my CV with him. And the CV is important. Once I thoroughly read the job description, I tried to handcraft a CV template I have to match keywords and make sure that my experience sounded very tailored to the position. And the manager thought it was good, so he encouraged me to apply. And then within a span of a week or so, I was invited for this take home interview assignment. And I was also asked to apply formally, which I did. And the formal application required a cover letter. So if you are going through these back channels like LinkedIn and it's working out, a cover letter is really never required and no one reads it. So just use ChatGPT to make it. Do not waste your time making cover letters. So this is just the process of landing the interview. Let's move on. So as I said, I have a history with this company and I've sort of known the people here. I've even applied in the past and I've always been rejected. So what changed this time around, right? So my CV evolved. Most importantly, I had a publication in this relevant field, and I think that added value. And the next big change in my CV was that I had a bullet point related to machine learning, right? I had tangible, valuable experience. I'd added real life, real world, valuable experience, right, in machine learning by teaching PhD level classes on PINNs. So I mentioned that, and I tailored my CV so that keywords were matching. So how did I go about this process of tailoring my CV? So first I went on to the website, not the website, sorry, the LinkedIn post had the link to the job description. I went there, I looked at it and I tried to like extract keywords based on reading it, which have great synergy with what I do, right? So I've looked at it and like research engineer, algorithm, again, state of the art algorithm, machine learning, motion tracking, emerging research trends. So relates very well to my skills, where I'm headed, so things I can use while editing my CV. Again, looking at the job requirements, it says that they want someone with a master's degree in physics, a few years of experience, very strong mathematical, analytical problem solving background, and one of or more of the following fields. And one is machine learning, one is signal processing. They say that you require an excellent knowledge of Python, very good communication skills, and the ability to produce quick solutions. So I felt like I had all these things, and that was great. So I changed my CV accordingly. Now, the challenging thing is, all this is great, but my machine learning experience really comes from PINNs, physics informed neural networks, which are niche, but they're extremely valuable. And as I've mentioned time and again, they're this bridge between physics and engineering and machine learning, scientific machine learning or PINNs. But how do you actually put those words or use those terms in your CV? Because if you just put PINNs, it might scare people off, or it might not be well received by if someone just reads PINNs. Might sound obscure. So the idea is to just keep your CV very high level, very broad terms like algorithm development and machine learning. And under machine learning or adjacent to your machine learning, you can use like talk about PINNs. So in my professional summary, I include interest in machine learning, and that's there. In my skills, I say machine learning, and next to that, I talk about PINNs. And my employment history, I talk about the real world experience I have with teaching PhD level classes on machine learning. And within that bullet point, I talk about PINNs and automatic differentiation and PyTorch. So it's like a sub bullet. The main bullet should always be machine learning, and you can talk about it right at the top in your professional summary, in the skills, and like your employment section. Okay, so all of this happened. I got the job interview. It was a take home assignment. What was this assignment about? So, it's a company which is very well known for developing wearable sensor technology, and they use it in a wide range of applications: sports, biomechanics, robotics, medicine, like even making movies. Like they have wide range of applications, but their core technology is building inertial measurement unit IMU sensors for motion tracking. And one of the really key important problems in this field is you have this sensor, you can place it on any object and the object moves around, and you want to describe how the object is rotating in space. So it's called inclination and heading angle estimates. A classic example from the literature is your aeroplane. So you have an aircraft flying, and the aircraft rotates like, this way, it can rotate this way. So you have this angle called pitch, this is roll, and it also goes this way, this is yaw. So that's a very typical example of how an aircraft rotates, and you need this in navigation systems. So this is a very standard and well-known problem, but it is still a research problem because there's no one solution, and you can be very innovative with this. So they gave me a data set of IMU data and said, just predict the orientation, provide with us with orientation estimates. That is the problem. And I'll give you more concrete context, something we could maybe relate to a fun example. So given that the Cricket World Cup, T20 World Cup is going on, here you have a figure generated by DAL-E using some prompt engineering of Virat Kohli hitting a cover drive. And just think about a very futuristic scenario where you have Virat Kohli with all these sensors in purple, and he's hitting a great cover drive, and you have all these fancy statistics where you're actually tracking the angles of the bat and the angles of like elbows and the knees, and that's giving him like giving all the viewers and the scientists analyzing in movement a lot of information, right? And on your screen you'll have all these fancy angles along with your bowling speed and bat speed and score. So this is like a futuristic scenario, but in this futuristic scenario you could think of a bat with these sensors, or like your cricket kit with these sensors, and you have to track the angles and the orientation, and that's how you can actually describe the movement, right? So this is like a concrete problem from sports, very relevant in India and right now in the Cricket World Cup. So in fact, there are two startups in Bangalore, India, working on this technology. One is called Stance Beam, and it's Shikhar Dhawan, ex-Indian batsman, uh, uses this technology. And another one is called Spectacom, started by Anil Kumble, and it's actually in Bangalore. He's partnered with Microsoft, a very famous startup in the sports tech space. So people are actually doing this. So I thought of giving this example. Okay, so now we have discussed like getting the job interview and this problem which relates to sports and motion tracking. So why do I want to use pins, right? So one thing is, I was very personally very motivated and curious because I think it's a fascinating approach. I think it has a lot of potential. So you have this figure here, and it's been used everywhere from epidemiology to astrophysical and microscopic imaging to plasma physics, fluid dynamics, and even biomechanics. And this epidemiology example is from Raj's paper, who is a co-founder of Vijwara. Um, and this specific application that we're interested in is motion tracking and maybe biomechanical motion tracking. And one of the world's leading authorities, Scott Delp's lab at Stanford, said that the combination of physics and data is the future of this field. So I thought, well, if this piece of tech or method is being advocated as the future of this field, it might be a good idea to try it out. And I was motivated. And it has such wide range applications. So I spoke about an animation where you can actually visualize the pin at work in our introductory lecture, but we can quickly walk over it again just to sort of give you a feel for things. Let's see if it's, yes. So you can see with a pin, you're basically trying to model a quantity of interest that you want to predict. So for our case, it might be the orientation. In this case, we're just simply showing a sine wave regression problem. And then you have a neural network predict that, and you pass it through the physical law, and you actually compare it with the data you're given. And the goal is to reduce the error or have your predictions from the pin match with the data. And the way it happens is you have this optimizer block which is hard at work. You can see the wheels rotating to make these your prediction match with the plot, and you can see the yellow prediction match well with the blue data and the error gradually approaching zero. And in fact, if you watch this animation again, you can actually see the neural network edges like being highlighted. That's like the information flow going through the weights changing. So there's just like to tell you that your pin has different modules, and you replace the quantity of interest with a neural network, and your inputs might be like x, or in our case it will be time, and you pass that through the physical law. You actually compare it with the data you've been given, and then the goal is to sort of have them match perfectly by the error going to zero. And the way it gets done is through this machine called the optimizer, which like will help information flow back to the neural network through a process called backpropagation, and the neural network learns, and you finally are able to generate a prediction and find a quantity of interest, right? And it's very modular. So you have neural network, you have the comparator or the loss function, you have the optimizer, and you have the loss function history, you have the physical law. It's like modular, and those are the models. So in our specific case, I just wanted to show you what the pin architecture looks like. So we're interested in predicting orientation and how it changes with time. So you have time as an input, and it goes into this neural network, which you can see with the blue circles, and you have this sigma, which represents sigmoid activation. And you have this, and then we call this the shared block. And then after that, you extract positions, which are, you have these red weights going there, and then you extract orientation, and you do some processing to the orientation data because you want it in a specific format called quaternions. Then you do this automatic differentiation shown with these del by del t's and del by del t squares. You pass them through these physical models, which you have these equations here for the accelerometer and gyroscope, which are parts of the sensor. That goes to the loss function. You also have the data going through the loss function, and then the neural network learns through backpropagation. So this is the specific pin architecture, and we have a shared block, and then we have outputs for the position and orientation, which have its own weights sort of going away from the shared block, which are shown in red and green, right? And then you leverage automatic differentiation, have the physical loss setup, and learn through backpropagation. This is what the module and the actual code looks like. So you have this class for the position and the orientation, and you see all this JAX code with the initialization and linear layers, and then you have the call, which actually does the forward propagation, and you can see the activation and then some mathematical operations being done to sort of extract the orientation in the form we want, called a quaternion. And then you have these modules for the physical law, and you can see some terms like jack.jackref, and that being used twice in the accelerometer model. That's just automatic differentiation using JAX's reverse mode, right? So this is what the code actually looks like. And this is like the loss function, and you can see some weights and a boundary condition loss and things being added up. And that's what it looks like. And this is where the actual magic happens, the optimizer. And you see this line at x.filter_jit. This is like the power of JAX, like just-in-time compilation, which makes it run super fast, right? So this is where all the magic of the neural network learning happens. And these are some of the results. So you see like this loss history, when it sort of goes down, it's like telling you the error is reducing, and that's really good. You can see the error flattening out and very close to zero, which is great. And you can see the results. You have your actual data, and you have the pin prediction, which is matching really well. And you can see like it's going nicely through the noisy data, which is great. And this is the actual data we want, like the actual orientation, and this is one angle which is shown. And we have the reference data, which we didn't use to train the pin. That's just for comparison. And you have what the pin gives you, which is a great match. So you can see that the pin approach shows a lot of potential and promise. So, but there is a reality check, right? I mean, I told you how I sort of use pin for this job application process right from crafting the CV. But there are things to think about, like when you are trying to implement a pin directly for like a job interview assignment. The first thing is there's stress, right? There's like, is this thing going to work? Is this even been done? Because pins are relatively new, so you don't even know if this is going to like work out. And especially if you're using a framework like JAX or Julia, which is very powerful, but it's still not very well known, and it's still up and coming. It's not as popular as say PyTorch. So it is ambitious, it is a risk. You don't know how the employer is going to perceive it. They might get very impressed, but that is the main goal, to impress them and sell them this idea that, hey, I am a candidate who knows domain knowledge and has ML skills, right? But it is stressful because you have to get this whole thing to work in such a short period of time. And like once you start doing it, you'll actually realize, since this is not done, this is sort of a research project. So trying to get it done under 1 week and then get the documentation and presenting it is stressful, and any small mistakes might trigger anxiety because you're faced with a deadline, and this might be a good job you want. So you really have to assess like the constraints you have. You have limited computational power, you're under stress to get this done, and you have limited time. So keeping that in mind, I developed a proof of concept, and I just tried to get a working skeleton to demonstrate this approach has potential on like a small slice of data, and sort of bring in some of the conventional ideas. I did do some comparisons with conventional methods, because conventional methods demonstrates domain knowledge. And by showing a proof of concept on a small slice of data, you should also be able to show limitations, which will very naturally lead to next steps. Otherwise, it feels like it's a scam, right? It feels like you're cheating by just trying to get some small slice of data and show it works because it doesn't work anywhere else. So that should not be the case. You should be able to figure out slices of data which are very representative of what is actually happening, and show cases where it works very well, show cases where it fails, why it fails, which I haven't shown you here because I wanted to give you a broad overview. But the main point is you want to sell that it works, show proof of concept, show a working skeleton, and then sort of show where it fails also and why it fails and how you can improve it. Be very clear with your communication, right? And when we say get a working skeleton, that also means all of this Jack's code, right? Because one of the key things they want to look at is, can you write very good code? If you can use a cutting edge machine learning library and get a PINN up and running in 1 week with the stress of that interview and be able to present that, that puts you in good standing. And I hope that I've sort of demonstrated that PINN has a lot of potential. And if you use it the right way, you should be able to even use it for job interviews practically. When it comes to the CV, you do want to sort of focus on machine learning and PINN being a subset of that. And when it comes to the actual interview, if it's this take home assignment format, you do have enough time to try something as ambitious as PINNs with Jacks, but you still need to be very realistic about your resources and making sure you're able to get something working with good results while also knowing its limitations and communicate everything. So PINNs is very powerful. Hopefully this gives you a better understanding how PINN fits into the bigger picture, how it can help you transition to machine learning if you come from a core scientific discipline. And I hope I also told you how you can actually use it in a real world situation involving like a stressful thing like getting a job, right? For a job interview. And right now, we're like the plan for this series is tentative. We are experimenting with a lot of things. So we might continue with sort of this broad introduction style and talk about sort of where PINNs are not to be used and maybe conventional methods or generative AI tools are better, like maybe ChatGPT versus PINNs. Or we might do something different, or we might do a technical deep dive into a topic like UAT. So things are still like very fluid right now. So we might continue the introduction, we might go deep, we might even sort of do a full-fledged like video with a hands-on tutorial of all this actual code if you're interested. So it might be a great idea if you can drop down in the comments what you would like to see in the next video. And I hope you enjoyed this. I hope this gives you confidence that you can learn PINNs and you can actually transition to ML from a scientific discipline and actually crack a job interview question for a research engineer position in 1 week using PINNs. It is possible. I was someone who did not know PINNs and deep learning a year ago. Okay, I was like sort of exposed to conventional methods, and now I'm at the point where I can crack a job interview question for a research position in 1 week using PINNs and Jacks for a problem I've never seen in my life, right? So it is possible. I want you to have that belief, and I want you to know that PINNs is the future and it's being used widely. So embrace this idea, embrace AI, look at other videos on our channel, and I hope you take something away from this. I hope you gain confidence about PINNs and you see a way of how it fits with your personal story. And please drop down in the comments what you would like to see. If you would like to see ChatGPT versus PINNs, or if you want an in-depth video about the actual code and the actual detailed PINN I coded up to crack this interview. Or if you want to see a traditional math topic like universal approximation theorem. Let us know in the comments below and we'll meet in the next video. Peace.